Today we are going to talk about slope. Slope is basically an idea that helps us communicate which line is steeper given 2-3 lines. So let's say we have a line over here, line A, and another line, line B, like this. And we have to communicate and we have to actually figure out which line is steeper. Okay, over here you can actually have a look at it and say that okay, line A looks less steep compared to line B, right? Well, visually it is very easy, but if you have to tell analytically, maybe if you have to figure out a way to communicate to a system, a computer maybe, that which line is steeper, how will you do that? So slope is one method to do that. Okay, so how do we achieve this is, basically we take one point on A and then we take another point. Let's call our point P, Q, okay? The coordinates of these points, let's say, is x0, y0 and x1, y1. Fine. So what we do over here in this idea is that one way of going from P to Q is you walk horizontally. You walk horizontally until you reach vertically below Q and then you climb to Q. Okay. So horizontal walk and then vertical climb. Fine. So this distance that you covered, this horizontal walk that you covered, that will be given by x1 minus x0, which is represented as delta x, or delta is basically difference. Delta is a symbol that denotes difference, right? Now over here, the climb that you made, the vertical climb that you made, right, here that will be y1 minus y0, or your delta y, right? Now what slope of this line will be, that is your delta y by delta x. Fine. So this basically tells how much did you climb by how much did you walk. So let's say in this case you had to climb 5 units when you walked 5 units. When you walked 5 units horizontally, then you had to climb 5 units vertically, right? So your rate of climb per unit of your walk will be 1. So this is one method to communicate that. Here again in the line B, what you will see is if you're going from point P to point Q, okay, so you walk horizontally and then you climb vertically, right? So again over here, x0, y0, x1, y1, this will be your delta x, fine, and this will be your delta y. Here your slope will be again delta y by delta x. Let's say in this particular case, since the delta y looks bigger than the delta y over here, right? So over here the delta y, let's say, is 10 for the same delta x of 5. So here our slope comes out to be 2, right? So over here we can say that the slope of line B is greater than the slope of line A. So line B is steeper than compared to line A. Another thing to notice over here is in the given triangle, this triangle, if I say that the line makes an angle theta with the x-axis, then the slope that we just found out was our delta y by delta x, right? So in trigonometric ratios, this can be represented as tan of theta is equal to delta y by delta x, right? Which is your slope we just found out, right? This full thing can be also represented as tan theta. Here in this example, line B also, if line B would have made angle theta with the x-axis, your slope would have been called tan theta, right? So you would have just found out this angle theta with the x-axis and then found the tan of that, and that would have been the slope. Now let's look at some different examples. So if I give you a line like this, line C, here if you walk from point P to point Q, you're not climbing up, but you're climbing down. Okay, you are climbing down. So here in this case, your delta y is going to be negative, delta x will be positive, right? So your slope will turn out to be negative. What is slope? Delta y by delta x. Delta y is negative, but delta x is positive, right? So your slope will be negative for this particular line. Even from the point of view of angles, if we see from the point of view of angles, this line is going to make an angle of theta, which is an obtuse angle. Okay, this angle is an obtuse angle with the positive x-axis, right? Now, tan of obtuse angle is negative. If you don't know about this, then don't be afraid. You will be learning this later. Now, let me give you another problem. What will be the slope of a horizontal line? A horizontal line, okay? So here in this case, let me take another point, P and Q. Fine, some random points. Now, if I walk from P to Q horizontally, then I won't have to climb up or down, right? So delta y in this particular case will be 0. So slope in this particular case will be 0. Now look at the same problem from the point of view of angles. What is this line? Let's call it C, making an angle with the x-axis. Well, the angle is 0, right? And we know that tan of 0 is 0. Let's try to summarize this with an example. Let's say we are given with a function f of x is equal to 2x. Well, f of x is nothing new, but it's just another way of saying y is equal to 2x, right? You know that this is going to be a line. I think you would have drawn this many times. Newton standard. So line will be something like this. Okay. Over here, when x is 1, your y will be 2. When x is 2, then your y will be 4. When x is 3, then your y will be 6. This is what your line is going to look like. So over here, if you have to find out the slope of this line, or the rate at which your y changes with x, change in y by change in x, the rate at which your y changes with your x, then you find out the slope of it, right? The slope of it denotes the rate of change of y with respect to x. And one way of doing that is you take one point and you take another point Q, okay, and then you walk horizontally until you reach vertically below Q, and then you climb vertically. Okay, now this is gonna be your delta y, this is gonna be your delta x. Your delta y is what? 4 minus 2, and your delta x is 2 minus 1, right? So this is 2 by 1. This is your slope, the slope of this line. And the beautiful thing about line is that if your friend would have taken any different point, let's say he would have taken this point, let me use another color, let's say he would have taken this point R. Now in this particular case, okay, in this particular case, what slope would have he found? So for him it would have been 6. Delta y would have been 6 minus 2. Correct, this thing, right? And your delta and his delta x would have been this thing, which is 3 minus 1, right? And his slope would be 4 by 2, which again comes out to be 2, right? Just like your slope. So for a straight line, the beauty is the slope never changes. The slope is always fixed. Well, you can see that from the angle's point of view also, right? Let me draw this again. This is your y-axis, this is your x-axis, and let me draw a line. Y is equal to 2x. Okay, now since this is a straight line, if you find out the angle over here at this point, this will be, let's say, some theta. The angle that will be over here at this particular point will also be theta, right? At any other point, if you find out the angle that it makes with the positive x-axis is always going to be the same. So tan of theta at all these points is going to be the same, and hence the slope of this particular line is going to be the same. Fine. Next, what we learn is the slope of a curved line.